want to start. So we are doing review for the test 5. And we are doing no 1, 2, 3, 4, 5. We are doing, for example, 17, 18, 19, and 20 that belong to the topic we don't cover in the regular lecture. Remember, we lost today and holiday, and today is a huge because it's 2 hours, no? So okay, but don't worry, this is easy. And after 16, que is a mathematical induction, you never see before that. Okay, so let's do this. 17. 17 is 2x plus 3 to the 5th power. Okay, so they are a formula to expand the binomial theorem. Of course, we are doing the traditional multiply 2x plus 3 times 2x plus 3. You fall 5 times, but this is crazy. No. What is the formula for the binomial theorem? A plus b to the n power is equal to summation from k0 to m of the combinatory number nk. I want to explain it in this part. A to the n minus k, b to the k. And we have a lot of variables. We have k is the index variable of the summation. So the summation go from 0 to m. It's exactly the same as the same spot. Entonces you have the first is A and the second is B. I call A and B, but no se matter. For example, in this example, A is 2x and B is 3. And M is 5. N is 5. Entonces, when you expand the binomial theorem, we obtain from 0 to m, you obtain n plus 1 term. You include 0, 1, 2 to n. Entonces, now, for example, let me read that part. For example, see you, for example, entonces the confusing part is, what is that? What is combinatory? I want to explain the formula, but I want to explain another way to find that super easy, que is using the Pascal triangle. Pascal triangle look like that. 1, 1, 1, 1, 1, 1, 2 in the middle, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 10, and 1. So what is the regular idea to control the Pascal triangle? So this diagonal is always 1. And this is formed by, well, this is 2, okay, but this is 3, is formed by the summation 1 plus 2 is 3. 2 plus 1 is 3. This 4 is 1 plus 3 is 4, and so on. 3 plus 3 is 4. You form any. For example, that 5 is 4 and 1. 4 and 6 is 10. 4 and 6 is 10 again. And 4 and 1 is, this is 5. Sorry, this is 5. It's obvious it's 5. This is 5. For example, what's the next row? Is 1, 6, 15, 20, 15 again, 6 and 1. So 6 comes from the summation 5 and 1, 5 times 10, 5 plus 10, sorry, 15, 10 plus 10 is 20, and so on. Entonces, bueno, no, okay. Entonces, you understand a little bit, but not full, not completely. Suppose que you expand a plus b squared. Well, you know very well by memory guess a squared plus 2ab plus b squared. Entonces, that coefficient c, que es 1, 2, and 1, is exactly this coefficient. 1, 2, and 1. Suppose now that you are doing a plus b to the 3rd power. Oh, entonces we have 4 terms, because in between 0 and 3 we have 4 terms, and the coefficients are 1, 1, 3, 3, and 1. Entonces, okay, 1 is invisible, but it's a cubic, according to the formula. Look, suppose for k equals 0, k equals 0 is 3 minus 0, and b0. Entonces, b0 es 1, entonces a cubic, only a cubic, plus 3, where come from 3? This is this 3. So you're decreasing the exponent of the A and increasing the exponent of the B. This is the idea of this exponent. A minus K decreasing, K increasing. Therefore, next is also another 3, guess this 3. A to the 1, because 2 minus 1 is 1, and B squared, plus 1, guess the last one, is B cubic. Do you understand? Do you understand or no? Confusing. Come on, opinion. Elite. No, Edward. 100%. What part is confusing? Come on. Another way to compute this combinatory number. This is combinatory number, NK. Que represent the coefficients. Well, we can use in Pascal. But the only disadvantage of the Pascal is n equal 20. So it's too long triangle. No, we can use and it makes sense with the Pascal. Yeah, but what is the disadvantage of the Pascal? Suppose n equal 20 or 200, entonces too long Pascal triangle. Entonces es 20 is possible, but 200 is impossible. Too long. So there are formula for any position here. Nk is n factorial divided by k factorial a minus k factorial. This is the formula. And what is factorial? Factorial is, for example, 5 or 4 factorial. What is 4 factorial? Factorial is exclamation sign. It's a symbol, mathematical symbol factorial. It's a multiplication of 4 times 3 times 2 times 1. So from 4 to 1, decreasing. It's 12, 24. This is the idea for this. And the combinatory number, for example, let's see example to understand. Suppose I want to compute these 3. Okay, this guy, okay, so you expand using the formula for the Newton binomial theorem is 30, combinatory 30, a cubic B0, because this is for k equals 0. Plus, now k equal 1 is 3, 1, A2, B1 is this. This is for k equal 1. Plus, combinatory 3, 2, A1, B2. This is for k equal 2. And that k es 2, entonces M es 3, y 3 minus 2 es 1. That's the reason que exponent is 1 here, and k is 2. Plus combinatory number 3, 3, A0, que obviously A0 is visible, 1, B3. Entonces now, let's go to the formula to verification. Okay, we get the same answer using this formula. Okay, look like weird, but actually it's not weird. And the most of calculators have a special combinatory number inside the probability menu, so you can put combination. So it's no big deal computing this way. Okay, now, for example, let's pick this. This is combinatory number 3, 2. It's equivalent to say 3 factorial divided by 2 factorial, 3 minus 2 factorial. This is the formula. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. And 3 minus 1 factorial is 1. And 1 factorial is just 1. The bar is cancelled and the answer is 3. Do you understand? More clear now? No? Confusing? Okay, let's do it. Let's do it using the, let's do it in the example. And the example maybe clarify the idea. Suppose 2 to the 2x plus 3 to the 5th power. And you need to expand everything. And we using, remember, is this is 1, 2, 3, 4, 5. Okay, this is 5. N equal 5. This is n equal 6. This is n equal 4. This is n equal 3. This is n equal 2. And this is n equal 1. For phi, the coefficients are these. Is 1, is 5, is 10, 10. And you taking, for example, the first guy gets 2x to the 5th power, no? And 3 to the 0. Because the summation of any exponent always is m. Look, you adding mentally a minus k plus k. It's obvious that k cancel and stay only m. This is super clear. Look, the exponent is 2 and 1 together is 3. And 1 plus 2 is 3. Always the summation of the exponent in the variable is 3. In this case, the summation is always 5. So you can put 3 to the 0 because b is 3. But this is 1, you know. You don't need to write that. What is the next? Well, the next is the coefficient f5. Look, I am trouble, I did that. Now next is 5. 5 times what? 2 to the x to the 4th power. Because I decrease in 5 minus 2 to the 4 and 3 to the 1 power. And remember 4 plus 1 is 5. Plus, what is the next coefficient? 10. 10 2x to the 3rd power and 3 to the 2nd. Plus, let me go down, continue down. What is the next? Is 10 again. 10 again. 10 2x pero to the 2nd power, decreasing. And 3 to the 3rd power, increasing. This is 1, 2, 3. This is 4, 5, 4, 3, 2. And next is 1. No? Entonces, plus 5, que es the last coefficient. 2x to the 1 power and 3 to the 4 power. Of course, you don't leave it like that. You need to are doing the operations inside here. It gets super easy. For example, 2 to the 5th power 32, x to the 5th power, plus, and you multiply 3 times 5, 15, and 15 times 16, and 16 come from 2 to the 4th power is 240. 40 x to the 4th power, plus, this is 8, this is 10, this is 9, together is 720 x cubic, plus, this is 4 times 10 times 9 is 1080 x squared, this guy, plus, this is 81 times 5 times 2 is 810. We have 1, 2, 3, 4, 5. I forgot 1, okay, 6. Okay, the rest is 3 to the 5th power. And 3 to the 5th power is, this is x, right? X. I forgot this x, guess this x to the 1 power. Plus, the last is 243. So basically we have 1, 2, 3, 4, 5, and 6 terms, que es the expansion of this binomial 2x plus 3 to the 5th power, or we have one more term than the exponent. The exponent of 5, when you expand, you have 6 terms. This is clear or confused? All right, clear. Okay, Jenny, this is clear. Okay, entonces now let's move on to next example. Next example is easier. Is 18. 18 is W minus S to the 6th power. Obviously, we expect 7 because 6 plus 1 is 7. And the first one is W. So what is the problem, Professor? Because the formula que you show me is A plus B to the 6th power, maybe, no? And now it's minus. Okay, no problem. Si es minus, entonces you apply the same formula, but you consider que es minus B to the 6th power. So actually, it's the same formula, but you consider que A is W and B is minus S. And we apply the same formula. So the only problem is que the even exponent of the S stay positive because, you know, negative S raised to the even exponent is positive. However, the odd, no. The odd is negative. So we start for W6, no? It's the first. Minus, entonces we're using the Pascal or the formula is 6. Entonces we're using this factor. Look, 1, 6, 15, 20, 15, 6, and 1. 1, 2, 3, 4, 5, 6, 7. Okay. Entonces es 6. 6. This one was this. Okay, it was invisible. 6 W5 S to the 1 power, pero es negative S to the 1 power que es just negative X. So at the beginning, I don't know. I put plus here. I put negative S to the 1 power. Okay. Pero es negative S. Entonces, much better, more convenience. Right like that. Put a negative in the front. And the exponent for the S is 1. It's invisible, right? Plus or minus, I don't know. I suppose que es plus. I start alternating negative, positive, positive, negative. Entonces, 15 W4 X squared. That is the reason because actually it's minus X squared. And minus X squared positive X. Entonces, it's easy to understand que the even exponent of S become positive, the odd exponent of S is negative. Minus 20 now is 20 W third X cubic plus 15 W squared. Let's see, W X cubic, 15 W squared X to the 4th power. Remember, one important thing to check and see we are doing well or no, you add in the exponent. 3 plus 3 is 6. 2 plus 4 is 6. 5 plus 1 is 6. Plus no, minus. Now it's minus. Minus what? Minus 6. Is this. W to the 1 power, S to the 5th power. Plus, guess the last one, S to the 6th power. In total, we have 1, 2, 3, 4, 5, 6, and 7. Cool. Do you follow me? Okay, Edward. I want to change using the same formula, but I want to change a little bit the problem. The problem is not expand completely the binomial. No. It's find one specific term in one specific location. Of course, we can do everything and select the information that is required, but this is not the best way because maybe it's too long. So now I want to explain in detail this idea. Look, the example 19 and 20, it's different. It's not complete expansion. It's find the coefficient of X in the expansion of the binomial 9x plus 6 cubic. Oh, it's easy because the cubic is only 4 terms. However, well, let's do it in the traditional way, but no. Let's do it directly. So I know that the formula for the Newton binomial Newton is nk a n minus k bk. Entonces now a in our problem obviously is 9x and b in our problem is 6. However, they want one term in the middle of this function que x is to the exponent 1. So we have only one x, no square, no cubic, no, only one, exponent 1. Entonces I assume que es x to the 1 y a es 9x. Entonces I suppose in my imagination, bueno, okay, n is 3, es obvio. K, no idea. Because I have no clear in what position is. But a is 9x raised to the n minus k. Pero n is 3. Sorry. N is 3. K, I have no idea. And b is 6 raised to the k power. But the condition, so when you expand this, I saw here in that part that we have x to the 3 minus 6. And the problem says that they want that this is x to the 1 power. Therefore, the conclusion is 3 minus k is equal to 1. Now solve for k. 3 minus 1 equal k. Es obvio que k es 2. Actually, it's not the second, it's the third. Because remember, the binomial start always as 0, 1, 2, and 3. 4 terms. So they want this guy. K equal to. And entonces the rest is super easy. It's basically, I come back at the beginning. It's combinatory 3, 2. Because k is 2, 9x raised to the 3 minus 2 que es 1, and 6 raised to the k que es 2. Okay, and combinatory 3, 2 is 3. Use the formula or using Pascal triangle. Suppose que I don't like the formula. Pascal is easy because it's 3, 1, 1, 2, 1, 1, 3, 3, 1. We are talking about this guy, 3. Because it's located in the position 2. Remember, this is 0, 1, 2. And this is n equal 3. And entonces multiplication by 9x, multiplication by 36. And the answer is 972x. Boom. Final answer. Any question? So it's not clear, the position. However, you infer the position for the clue que is given in the problem. And the problem, the clue que is given is, I want que you determine the coefficiency of or the term in general que contain x to the 1 power. Entonces now, pero 1 is the exponent of the x, pero no necessarily es k. Because in the formula, si n is 3, 3 minus k is 1. So you determine the k, and yeah, when you have the k in your hand, the rest is super easy. Super clear or no confused? Let's move on to the next 20, que es the last example of the review, pero es the last example of the binomial theorem. And in the test, you see problems similar, no? You see problem in which you expand everything. Of course, not too complicated, no 5 or 4, but no 200 ni 20. Okay, another problem is you can find a specific a term in one hypothetical position. For example, in the 20, you have the binomial like that. X plus 3y equal no, raised to the 10 power. Entonces es obvio. Looking this, que en este, we expect 11 terms from 0 to 10. I suppose que A is X and B is 3Y. That's important because not always it's a combination of the letter. There's sometimes combination number and letter, no? Entonces, in the original formula, we suppose just A and B, but no, in this case, B is 3Y. So now I come back, pero day one, ya, in the position 9. Position 9. 9 term. And the position 9, this is confusing, is K equal 8. Yes or no? Let me try to explain this. When you expand this, we have K 0. This is K. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Stop here, 11. This is my first term. Second, entonces now es, si you want in the position 9, it's the first, second, third, fourth, fifth, and so on, 6, 7, 8, 9. Entonces K is 8. Do you see? It's a 10th, 11, and 12. Actually, we have 11 turns, but in the position 9, K is equal 9. Now, this is the only difference. I go to the formula say the combinatory number 10, 8. It's the coefficient we use in calculator or by hand, either way. A is X in our problem, raised to the N, que es 10 minus A, que es K, and B is 3Y, and raised to the B, raised to the K, sorry, que K is 8. Okay? So now, let's use in the calculator maybe. Unfortunately, well, you try to find in your own calculator, the majority of calculator, for example, I have one elementary here, TX30. Okay, you have one key que es called PRB. PRB is probability. So when you, for example, press that key, putting on, press that key, you see a menu of the combination. So you try to find one combination that's called UNCR. What means that? That means combinatory. It's exactly this. Now the syntaxis in this calculator I have in my hand now, you put 10 first, you put NCR, and you put A. This is equivalent of this. Okay. So I clear the display, I put 10, I type in 10, I press the key PRB, select the option on NCR, you put A, and the answer is 45. So this number is 45. And this is X to the second power, no? Because 10 minus A is second power, and now 3 to the A power is, wow, put it in the calculator quickly, is 6,561 Y to the A power, no? And now multiplication, everything, 45 times this number is 29, No, 29, no, es 295,245 x squared y8 is the final answer. Do you understand that or no? All right, let me see if I can show you. Because every calculator is different. You need to investigate in your own calculator. Pero the majority of calculator is in PRB. PRB key. PRB. Okay. In this moment, you have your calculator in your hand right now, or no? Joshua, Gigi, Kelly, Faisal, Rachel, Jenny, Gladys, Natalie. Okay. Okay, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9 students. Okay, cool. Let the 9 students want to pass. Remember, everything is due tomorrow at midnight. Submit the test number 5 online and send me the test number 5 on paper. And the student can consider que need to improve, you have the possibility of the final. That's it. No more extra credit. No. This is my rule. Okay? Do you understand the last problem or no? No? What part's confused? Come on. Let me see if I have a calculator to show you. I don't plan in this idea, but I try. Okay, we have calculator, virtual calculator. Let me try. Select, copy, open browser. Okay, you Control C. Control V. There you go. Functions. Oh, there you go. Okay. Let me show you. Let me share the screen with the calculator. Okay. Here. Okay. This is not the same of your own calculator. Press something to see. Do you see the calculator? Oh no. Yeah. Okay, cool. Okay, I lost. Okay, there you go. Because the problem that we are solving was combinatory. Combinatory is this. Look, this key. I have no idea. To say you select in the functions, and this is different. Select combinatory number, and you put 10. I'm using the numerical and then my keyboard. 10,8. 45. Do you see a 45? A 45. Okay, this is the way. Clear? Clear or no? You try in your own calculator. Switching to the whiteboard of what the hell. Okay. This is the whiteboard. Do you see whiteboard, huh? No? Okay. Let's move now to equation 17. Equation 17 we don't cover in the lectures. And that's it. That's the only one we don't cover. Binomial theorem and mathematical induction. So I need to prove 2 plus 5 plus 8 plus dot 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 2 3n minus 1 is always equal m over 2 3n plus 1. Okay, so what is the idea of the mathematical induction? Mathematical induction have 2 steps. So a fantastic way to prove something in mathematics. Okay, entonces now you are doing one basic step. In general is for n equal 1. Entonces you replace n equal 1 here. Entonces 1/2 3 times 1 plus 1. 3 times 1 is 3 plus 1 is 4 divided by 2 is 2, que is exactly the same the first. So when you're plugging in this expression n equal 1, you get the first. So you plugging in 2. Let's do it quickly, but no. Basic step for n equal 1. What is the only detail? Because sometimes not necessarily working for n equal 1 until you try for n equal 2, and you discover that, for example, n equal 2 is true, and continue true in 3, 4, 5. So not necessarily n equal 1 is, the majority of the example, yes, but not always is true. But when you get true, okay, no problem, you complete the basic step. Okay, not necessarily 1, but in this example was 1, nice. Yeah, and the example I put in this subject, always I intentionally put because this is true for n equal 1. And we have another guess, the inductive step. Inductive step. This is a little bit more complicated to understand, but it's easy. You assume that S sub k is true. And k is totally arbitrary. Suppose this is n equal 1, this is n equal 2, this is n equal 3, and I call k one guy in the middle, n equal k. Totally arbitrary. So k is smaller than m. I assume. See, if you will be able to prove that S sub k imply that S sub k plus 1 is true, this continue forever. Continue forever like a one, suppose stairs like that. You prove that S1 is true. And you continue 2, 3, but no. Because maybe another example, si you continue, suppose que it's not true in the 200, entonces not true for everyone. Entonces you assume one intermediate, and you suppose que SK is true. This is assumption. And you will be able to prove that the next, que x plus 1 is also true. So not exactly, the implication of this, que is true, determine this. So this continue forever for any k belong to the natural number. This is the idea. It's like a one, remember the game, can you put a piece of domino like that? You have the piece of domino, you put together, close it, and you push it one and bring down another, moving another, and this motion continues forever. This is the idea of the mathematical induction. So let me explain. It's super easy and super powerful. Look, suppose in the inductive step, you assume that S sub k is true. And who is S sub k? I am confusing, Professor. No, it's the same thing que given at the beginning, que is 2 plus 5 plus 8 plus but you don't finish in n, you finish in k. Entonces 3k minus 1 should be equal k over 2, 3k plus 1. Okay, I copy. Instead of m, I put k, I suppose k is one number smaller than m. Entonces now I try to investigate what's going on in a sub k plus 1. Oh, it's easy. You copy the same. Include this, of course. And you adding, you adding the next. What is the next? The next is 3k plus 1 minus 1. Okay, que es en ordering is one more after k, ¿no? Suppose que k is 400, 401. And the right hand side, we are doing exactly the same. You replace k for k plus 1. K plus 1 over 2 and 3k plus 1 plus 1. Okay, close the parentheses and that's it. But the assumption we are doing was okay, that part is equal this. Que is k over 2, 3k plus 1. Plus. Okay, plus what? Plus this. And now algebra. Algebra, you distribute the property here. Entonces 3k plus 3 minus 1, que es plus 2, ¿no? Let me erase and I put plus 2 directly. Okay, this is equal. This is equal k plus 1 over 2. And here we have 3k plus 3 plus 1. Entonces 3 plus 1 is 4. Is plus 4. Plus 4. Everyone follow me, guys? Yeah, the rest is just algebra elementary. For example, put together this least common denominator is 2. We have k, 3k plus 1, plus 2 times 3k plus 2. Now, bueno, distribute the property one more time. 3k squared plus k plus 6k plus 4 divided by 2. Why not? Combine later. Is 3k squared plus 7k plus 4 over 2. And for the moment, stop. Because I forgot the right-hand side of the equation, I need to manipulate now. And you see suddenly this is exactly the same of this. Entonces now, at least these two is division, and you FOIL. You FOIL. K times 3k is 3k squared. K times 4 is 4k. 1 times 3k is 3k. And 1 times 4 is 4. We combine later. It's 3k squared plus 7k plus 4. Wow, amazing. And this is exactly the same as this. Now I prove. Using mathematical induction, okay, this expression is given at the beginning are equal for any m belong to the natural number. This is the systematic way, guys. Let me recap. The mathematical induction has two steps. Step 1 is the basic. Frequently is at n equal 1. You plug it in the expression n equal 1 and you try to prove it's equal the first. You can continue. Yeah, you can. N equal 2 is 5, n equal 3 is 8. However, you never finish because it's infinity. Now you assume one intermediate value that I want to call k. And you suppose that the statement S sub k is true. It's an assumption. Now I investigate what's going on when the sk plus 1. See, I prove that it's true. This process continues forever, exactly the same when the piece of domino fall down. Bam, 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 for any natural number. The question? You understand the idea? I would like to explain more clear, more time, dedicate this. But essentially is this. Essentially is this. See, we have time. I want to illustrate another example. Complete out the one example that you very well know. The proof of this. Out the review, no? If you want. Not exactly. So now I broken the, we are doing the last problem. So we come back at the beginning. We start now number 1 question, right? Number 1 question. Okay, let me, wait. Let me move here. Okay. Let's move on to the last question. Okay, here. Wow. Okay. Erase. Mathematical induction. And erase, why not? That part. And that part. Okay. Let's move on now to the first page. ¿Qué es this? Okay. ¿Qué es the conic section? Elipse, parabola, hyperbola. Okay, look at that. I realize that the first question obviously is ellipse because it's 25 x squared plus y squared minus 350 x plus 1200 equals 0. Okay, so I need to determine everything. We need to do the sketch of this center, foci, vertex, and this is say the problem que es elipse. Es obvio que es elipse because it's x squared plus y squared. It doesn't matter que 1 is 25 and this is 1. Okay, so now complete the square. Complete the square. You select the x part, que es this and this. Put together. Y I factor out 25. 25x squared minus, entonces I divide 350 divided by 25, 14. And entonces you put a magic number que complete the square. After we found. And why no? Because y have no linear, look, have is y squared only, plus y squared, and no, we have no y to the degree 1. That means that this ellipse have shift in x direction, but not in y direction. Okay, I respect that. Equal, entonces I put in the right hand side minus 1200 plus another box that I have no idea what is the number you plug in. Do you understand the organization of this or no? Yes or no? Now the magic number, always you take big, 14, I don't care the sign, divided by 2 and a square. 14 divided by 2 is 7, and 7 squared is 49. So this is 49. The number que complete the square is 49. But the number que I put here is not 49. It's 49 times 25. Because don't forget, this 25 that we have here. So you introduce artificially because you need complete square. That 49, actually the number that you introduce artificially is not 49. It's 49 times 25. Okay, by the way, is 1225. Okay, so far, 25, you factorization this. Obviously, this is perfect square trinomial. X minus 7 squared is minus because this sign is negative. And we're confirm this 7 was the square root 49 plus y squared equal, in the right hand side we have 25, no? Because 1225 minus 1200 is 25. Now remember, to express it in standard, you divide everything by 25 because I would like that the right hand side must be 1. Entonces x minus 7 squared over 25 plus, no, coño, no 25. 25 is canceled. Look, this 25 and this 25 cancel. Okay, now stay only x plus minus 7 squared plus plus y squared over 25 equal 1. Nice. This is the thing I want. And guys, this expression is 100% equivalent to this ugly case given at the beginning that nobody understands anything about this ellipse. But for me it's clear that the center of this ellipse is located at the point 7, 0, because we have translation in x, we have no translation in y, because no, we have h is 7, k is 0, h is 7, k is 0. This is center. Now I know also that a square is 25, que es the bigger, therefore a is 5. And b squared is obvious que es 1, because we have here invisible, right? 1. Entonces b is 1. It's square root 1. Therefore, see, we are doing quickly by hand the sketch of this conic section. Oh, we can use in our software. Okay, I sent to you in Desmos. Let me try to find the rectangular coordinate system. No, not here. So let me see in here, over there. Oh, okay. I have here. Not good. Not good. Because it's in 7 and 7 is too far here. No, not good. Carajo. Well, okay. Don't worry for this. I try to do my best by hand. Suppose this. Y-axis, x-axis. And the center for this ellipse is located at the point 7, 0. Is 1, 2, 3, 4, 5, 6, and 7. That point 7, 0. Now A is 5. And remember, A is associated with the Y. So we have two possibilities. What kind of elixir we have? This elixir or this elixir? What do you think? We have horizontal elixir or we have vertical elixir? This is my center I found. But I need to decide, see the shape of this elixir is vertical or horizontal. What do you think? No, nobody have idea? You don't remember? And this is today, okay, we see that last week. Suppose que you es vertical, es vertical. How do you know que es vertical, Edward? Edward proposed me this idea. Everyone agree or disagree? And why? This no. Erase. Like that, no? Why? How do you know? What is the reason? Your identification que es vertical. Because the major axis, que phi, is located as or is associated with the y. But you see que 25 is a big number, is associated with the y. And it's phi. Entonces phi es, you know, 1, 2, 3, 4, 5. Here, that point. 1, 2, 3, 4, 5. Is this point. This is my semi-major axis, que phi, in both directions. Entonces this point would be 7,5, no? And this would be 7, -5. This is a major axis. 7. 7, no, 5, sorry. 5. Distance 5. And B is 1. B is 1, que is in the other perpendicular direction, is this and this. Is 1. At this point is the point, you know, 8,0. And this point is the point 6,0. No? So our elixir using a little bit look like that. Okay, so let me listing the most important point and categorize according to the importance. The center of this elixir located at the point 7,0. The vertex, okay, by the way, is this point, and this point, the vertex always is located on the major axis. Entonces es 7,5 and 7,-5. And the famous endpoints of minor axis is the point 8,0 and 6,0. And finally, the Fossey, I need to find the equation for the Fossey is, okay, C, and the elixir, the equation is different. It's like that, A squared minus B squared. So C is square root, que is 25, no? 25, 5, it's 5. So 25, so A squared 25 minus 1, que is 24. It's square root 24. Square root 24 is approximately, because it's irrational, 4.89. At the Fossey line, let me use another color here. Approximately at the point 4.89 positive, and another Fossey here, and the point 7, -4.89. Boom. This is the answer. Any question, guys? Do you understand very well? Oh no. Question. What part is confusing? Remember, we can do that using the software and Desmos. Okay. Do you remember the script I sent to you? You remember or you don't remember? Say something. We use it. You practice or no? Okay. Okay. So now let's move on to the next question, que es parábola. Parábola is easy. Parábola, well, wow, it's easy because it's giving already in super standard. Okay, I recall that we have two kinds of parabola, horizontal or vertical. Vertical, horizontal, and horizontal we have two possibilities, you know, open to the right, to the left, and vertical we have two possibilities, open up, open down. And this depending of the value of P, pero you immediately recognize que this equation look like similar to this. Y minus K squared equal 4p x minus h. Ok, entonces k es obvio que es 3. And h es obvio que es -4, right? And the vertex. In this case, the parabola have no center. It's vertex, que es this point. This point, this point, or this point is located at the point h, k. H, k is -4, +3. Okay. Now I compare also que 4, que es the coefficient que is given here, is equal to 4p. Es obvio que p es 1. Y si p es 1, que es positive, then the parabola open 1 identification. We are talking about horizontal parabola, no? Open to the right. Make sense? Open to the right. Okay, let me try to do my best in the graph by hand. By hand is June. The first thing you should do is plot the vertex, que es -4, 1, 2, 3, 4, and +3. 1, 2, 3. This is the vertex. Yeah, I know that this parabola open in that direction, no? Okay, I don't know exactly how narrow or wide there is, because depending on P. And the focus is always P distant and inside. So P is 1. This is the focus located here. At the point, -3,3, no? It's the focus. We have only one. And the distance diameter, the diameter is 4p. B is 1, this is 4. So we go 2 over 1, 2, because p is 1, and this distance is 2p, and this is 2p also. Okay, so we have the famous endpoint of the focal diameter. Okay, by the way, is, you know, -3,5. We come from this 5, 3 plus 2. And down was -3,1, no? -3,1. Guys, this is just common sense. No complication. It's just geometrical idea. You need to know that the parabola open to the right. So therefore, you infer that the focus is inside the parabola. Okay, something like that. Okay, now one more. This is the axis of symmetry. Okay, by the way, is the line y equal 3. And directrix is a vertical line and the same distance p. And p is 1. P is 1. So therefore, is x equal -5. No? The directrix. Yeah, directrix. This is the famous axis of symmetry. Wow, super easy. Any question that you don't understand very well? Cool. Of course, we are doing much better in Desmos, no? And you copy, make a screenshot, and attach to the test. Any question, guys? No? Sure? Do you follow me really or no? Okay, follow. Okay. Now the next is hyperbola. How do you know the hyperbola? Well, because it's minus. So you see the term que contain exponent 2 square, and you see the connection in between them es minus subtraction, entonces hyperbola. Si es plus, es elixir. Si es minus, es hyperbola. And si one of them are missing, es parábola. Okay. Entonces, always to confuse you, it's given a general form, and you need to modify algebraically in order to convert to standard. So now again, I see the x part. Okay, I put together x squared. Fortunate coefficient is 1, not necessary factor out, plus 4x plus box. Yeah, I complete the square, at least in the x part. Likewise, the y part and the y part. Okay, in this case negative, so I put negative 4, and we have y squared minus, I suppose que es minus because 32 is positive, but if you factor out negative and negative together, multiplication is positive. So it's minus 8y plus a box to complete the square. In the right hand side, we have 64 plus 2 box. Okay, this is the organization. Now, little by little, you complete this organization, complete the square here. It's obvious F4, no? F4, coño. Because 4 divided by 2 is 2, and 2 squared is 4. This 4, I put it here. Yeah, I put it here. But the second, no. The second is 8. 8 divided by 2 is 4 squared, 16. The 16, that number, 16. But actually, it's not 16, the number I put in the right-hand side, because when you multiply by 4, and when you multiply by 4, it's 64, but it's minus 64. It's minus 64. Do you follow me? Do you see that? Do you see that or no? You're the best. Wow. Now factorization. The factorization is x plus 2 squared minus 4 y minus 4 squared equal, wow, what the hell, look at that. 64 positive and 64 negative cancel out. Stay 4 alive. Now finally, in order to express in standard, you divide by 4 everything. Divide by 4 everything. Divide by 4 everything. The equation of the our hyperbola is x plus 2 squared over 4 minus y minus 4 squared divided by 1, because this 4 is cancelled, equal 1. Okay, hyperbola in standard. Equivalent 100% to the original ugly. Can nobody understand? Now, center. Well, no, center no. I need to determine what kind of hyperbola. Remember, we have two kinds. We have that kind, horizontal hyperbola, or vertical hyperbola. And that depends who is positive and who is negative. X is positive, es obvio que the transversal axis lie, at least not exactly on the x-axis, not parallel to the x-axis. So this hyperbola look like that, horizontal. And the reason I repeat again the idea is because the positive guys is associated with the x. The center, que es that point, center is located at the point, center is located at the point h comma k. Is minus 2,4. Minus 2,4, yes. Also a squared 4, remember a is not the bigger, like ellipse. See, a is associated with the positive, but this is a squared. Therefore, a is 2. And b squared is 1. Okay, the coefficient here is invisible, no? Therefore, b is 1. Okay. Okay, now ready to start plotting that. This is our rectangular, no? Coordinate system. The center is located at the point negative 2, 4. 1, 2, 1, 2, 3, and 4. Here. Ese is center. This. Y I know que our hyperbola look like that, but no. Let's do it in detail. Okay, entonces A es 2. Entonces es from the center, I'm moving 2 to the right and to the left. So we get one vertex here, que es the point 0,4, no? It's a vertex 1, and another is in another direction, 1, 2. Que es the point negative 4,4, no? Okay. Okay, nice. And B is 1. And remember to do the famous reference rectangular from this. You move 1 here, 1 here, 1 here, and 1 here. And this is our famous reference rectangle. Okay, the dimension is A in the horizontal direction, B in the vertical direction. And this is our asymptote. Okay, by the way, I want to determine right now the equation of this line. But this gives me some idea how it look like my hyperbola. My hyperbola passing through, let me show you here, vertex, and open in that direction and approach, but never touch the asset. And the other branch, exactly the same. That's it. No, I need the foci. And the foci is located in the distance C. I don't find distance C. Distance C is square root A squared plus B squared. Look at this different equation to elixir. In this case is C is equal 4 plus 1 is 5. Square root 5, que es 2.23. 2.23 using my imagination is a little bit, you know, this is the transversal axis. Transversal axis is on the transversal axis, and this distance is 2.23. That distance, C. In another direction, C. If you want to write the point R at the point negative 4.23, 4, and 0.23, 4. This is a foci. Okay, put in blue color. You are doing better in this. And the equations for the asymptote, these lines, is y minus 4 is equal plus or minus b over a, que is 1/2. Look, 1/2. 1 divided by 2. X plus 2. Remember, the formula for the asymptote is y minus k equal plus or minus b over a x minus h. Bueno, es the formula when you have a hyperbola like that. See, we have hyperbola like that, it's different. It's y minus k is equal plus or minus a over b. It's the same, but you flip it the slope minus h. But this is not important. It's important this, in our example, b is 1, a is 2, h and k, h is negative 2, k is positive 4. Any question? Do you follow me, guy? Or lost? Okay. Let's move on to summation notation problems and sequence. It's easy. Okay, look. Problem 4 and 5 is similar. Is summation from K1 to 16 of 2K plus 7. Okay. I apply the property of the summation que say que this number go to the front like a 2 times summation K1 to 16 of K alone, exactly as the formula say, plus summation from K1 to 16 of 7, que es a constant. So we're using the formula. The formula is summation from K equal 1 to M of K is equal M multiplication M plus 1 divided by 2. In our specific example, 2 is a factor. I put outside, and you put 16 times 17. Where I come from 16 is this number, is M plus 1 is 1 more, 17 divided by 2. So because these two is cancelled, and you just multiply 16 and 17. And here no, because no K is a constant, so you multiply 16 times 7. 16 times 7, this is 272, and this is 112, and together is 384. Boom. Final answer. Cool. Okay, recap. The factor you put outside the summation, like a common factor. You apply the formula of the summation K. And the other constant, que es 7, es a constant, entonces es repeated 60 times. Entonces es 16 times 7. 16 times. Clear?
Yes. Yes.
Who say yes?
Gladys.
Gladys. Okay, Gladys. Entonces now, number 5 is summation K3 to 5 of K squared minus 10. This is more complicated. Why? Because we have formulas of the summation that start in 1 to 5 or to M, but not in 3. So I need to break it down. Well, you break it down this summation from K3 to 5 of K squared minus another summation from K3 to 5 of 10. Okay. And suppose I try to compute this. But I make a mistake, no? F5. F5. I make a mistake in my paper. F5. Okay, because I fix it. Is this summation from K3 to 5, we can, of K squared, for example, you can compute it for the summation from K equal 1 to 5 of K squared minus another summation from K equal 1 to 2 of the K squared. Remember, the formula that we have in my property never start in 3, start in 1. Therefore, I need to break it down. So the idea is clear. The idea is I need, suppose, 1, 2, 3, 4, and 5. We need this summation. But we have no formula for this summation. We have formula for 1 to 5 and from 1 to 2. So you compute this and subtracting this, you get the red part. Clear? And the formula for the summation from K1 to M of the K2 is that formula. It's m more complicated. M plus 1, 2m plus 1 divided by 6. Okay, but no problem. We are doing. So now, let me erase that part. This is 5, 6. Welcome from 5 and 6. This is n and 5. n plus 1 is 6, no? And 2m plus 1 is 11, I guess so, no? Because it's si n is 5, 5 times 2 is 10, plus 1 is 11, yeah. Divided by 6. Ooh, entonces this cancel out this 6 by coincidence, it's 55. Minus, and the other formula is 2 times 3 times 2 times 2, 5. Divided by 6 again, F5. Because 6, 2 times 3 is 6, and 6 cancel out with the 6, is 5, so it's 50. Now this first summation is 50. This first summation is 50. This first summation is 50. This second summation, Remember, when you have a constant, you multiply 10 times 5. But in this case, you can do that when the k is 1, starting 1. But when it's 3, no. So now, what is the formula for this? When you take 10, but multiply by 5 minus 3, get the difference, plus 1. Why? Because actually we have no 2, we have 3 10. Because the first, okay, suppose k equal 3. The answer is 10 because it's a constant. K equal 4. It's 10 again, it's a constant. K equal 5. It's 10. And 10 plus 10 plus 10 is 30. Same answer you get if you subtracting 5 minus 3 gets 2. 2 plus 1 is 3. 3 times 10 is 30. What is the final answer? The final answer is 50 minus 30 is 20. Okay. You follow me? 20. A little bit complicated, eh? So you have your formula. The disadvantage or the problem is the formula is only valid when the summation is starting 1. See, the summation do not start in 1. You need to break it down in 2 pieces. Okay, and you can build separately using the same formula and finding the subtraction. Everything is okay?
Yes.
Okay. Let's compute now sequences. Sequences. The sequence. For example, it's given and we are doing number 6. A1 is -4. And semicolon common difference is 9. Wow. I need to find a sub n expression, explicit expression, and why not A6 in the position 6. The formula is easy. A sub n is equal to A1 plus n minus 1d. It's a formula. A sub n is equal to -4, okay, so it's the first, plus n minus 1 multiplication by 9. And leave it like that? No, of course no. You apply distributed, so we have A sub m is equal to -4 plus 9m minus 9. Is 9n minus 13. Is the formula for any. Specifically for 6, plug it in. It's 9 times 6 minus 13. 9 times 6 is 54. And 54 minus 13 is 41. Well, 2 answers we need. The general A sub m explicit formula for this specific sequence and in the position 6, the element is 41. Any question? Number 7 is similar. Number 7 is similar. Very similar. It's an arithmetic sequence. Arithmetic sequence, but A1 is 0. Ooh. 7 is similar. It's arithmetic sequence. The first guy is 0, and the common difference is fraction. 1 over 10. I don't care. The common difference must be positive, negative, fraction. Doesn't matter. Entonces, A sub n formula is the same formula of this. Okay, entonces A sub n is equal 0 plus n minus 1 multiplication by 1 over 10. Well, one possibility is right like that, n minus 1 over 10. Oh. And this generate any value. They want you find 27. They want you find A sub n and A at 27. Position. Entonces A 27 is equal 27 minus 1 divided by 10, and 27 minus 1 is 26, and 26 divided by 10 is 2.6. Oh, and fraction, you reduce the lowest term divided by 2 is 13 over 5. Leave it like that, or in decimal 2.6. It's the same. You know. Any question? Super clear or super confusing? Arithmetic sequence. Determine explicit formula and determine the Okay, now let's move on to number 8 and 9. 8 and 9. Well, let me erase using this tool, it's better. Okay. Okay, A and 9. A is one summation is given 6 plus 12 plus 18 plus and ending in 480. Okay. And this look like arithmetic sequence because the common difference is 6. 12 minus 6 is 6. 18 minus 12 is 6. D is 6. A1 is obvious que es 6. And A sub m, que is the last guy, is 480. And the formula say que A sub m in arithmetic sequence is equal A1 plus A sub n divided by 2. And everything multiplication by m. But the problem is I don't know how many because it's giving incomplete. This is n1, this is n2, this is n3, but this is n equal, no idea. Therefore, I using my famous formula, A sub m is equal A1 plus n minus 1d. Everything is given in that case. This is 480. This is 6. This is n minus 1, n no, it's unknown, I don't know. And it says 6. Okay, let's do it. Multiplication, in this case, is 400. Wait. To find the n value, you, of course, let me try. 480 is equal 6 plus 6m minus 6, no? Distributed here. Oh, it's canceled. Basically, it's 480 divided by 6 is m. Therefore, n is 80. This summation contains 80 elements. Wow, that's a piece of cake. Find the summation. Is the first one, que is 6, plus the last one, que is 480, divided by 2, and multiplication, whole thing, by 80. Boom. And the answer is 19,440. While you are doing this in the calculator. Okay. Okay, let's do number 9. No problem, guys. Do you understand very well where I come from the thing? Number 9 is a problem that we can solving. We can solving using summation notation or using arithmetic sequence. How do you know que es arithmetic sequence? Because the expression inside the summation is linear, exponent 1, no quadratic. Entonces, when this situation happens, it's obvious obey the formula for the a sub n equal a1 plus n minus 1d. Entonces, we can solve it in both ways, like a summation or no, or like a arithmetic sequence. I don't know why. I want to solve it by summation and the property, and if you have time and want, verify by the arithmetic sequence. So this summation is from n equal 1 to 27 of the negative 4m minus 2. Oh, easy, because starting 1 is a negative 4. You put outside the game and you compute this. And minus summation from n equal 1 to 27 to 2. Or negative 2. So you put positive here and you put negative 2, but it's okay. And the solution for this is easy. It's 27 multiplied by 28 divided by 2. Remember, it's n times n plus 1 divided by 2. And this multiplication by negative 4, no? And this is also easy as multiplication 27 times 2. And of course, subtraction. One of the answer of this is negative 1,512 minus 54 is negative 1,566. Boom. We can do that using the arithmetic sequence to find the first. No, but this is, in my opinion, is easy. In my opinion, I don't know. They are wrong and right. Okay, let's move on to the geometric. Geometry is given the first guy, A1, number 10. This is A, but actually it's A1. It's 4. Semicolon common ratio is 1/3. And they want to 5th term and the n term of this. Okay. I want to find the A sub m. I want to find the A sub phi. Okay, easy. The formula is different. In geometry is A sub m is equal to A1 multiplication by R n minus 1. Who is A1 for? Who is R? 1/3. Raised to the n minus 1. End the story. You can leave it like that. You can, if you want. Another possibility is 1 to the n to the any power is 1. So you put 4 in the top, in the bottom 3 to the n minus 1. It's another possibility. More elegant, in my opinion, to express the same answer. Because 1, is invisible number. Okay, when you raise to the any power is 1, and multiplication by 1 is nothing. Okay, to find a to the 5th power is 4 over 3 to the 5 minus 1. Okay, obviously 5 minus 1 is 4. Entonces es 3 to the 4 power, que es 81. Entonces actually is 4 over 81. Done. That part of the sequence is easy. It's no big deal. Okay, one more geometric. Geometry is A is negative 2, A1 actually. And common ratio is negative 5. Okay. The formula is A sub m is equal to A1 R n minus 1. A sub n is equal minus 2 times minus 5 raised to the n minus 1. Okay, entonces leave it like that because I don't know. You cannot say que negative and negative positive because depending on the exponent, no, si es even or it's odd. So much better leave it like that. Negative 2, you remove that parenthesis maybe. And negative 5 n minus 1. You want to find, for example, for the fifth power of the fifth position, s minus 2 negative 5 to the 4th power, no? To the 4th power, yeah. To the 4th power, but to the 4th power, I make a mistake here. Look, this is exponent like that because this is r to the n minus 1. So actually, this 4, 5 minus 1, the 4, is not here, it's here. Okay, and this is obviously 625 positive because the point is even. I multiply by negative is negative, 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 1,250. This is the answer, and this is another answer. Okay, let's move in now, so you have no question, to another paper, no? Okay, we need to finish. Remember, we have only 12, 13, 14, and 15, and that's it, guys. It's super easy. The complicated part was 16, 17, 18, 19, and 20. We did that. Okay, now suppose this. Suppose que es summation of the, pero summation and geometric. We have a specific formula. Look, I want to explain the formula again. We apply the problem again. It's a 2/3 raised to the 2 to the k power. So what is the formula? What is the formula for any summation that involve geometric sequence? The formula is A1, 1 minus r to the n power divided by 1 minus r. So now it's confusing here. Who is A1? So my recommendation is you evaluate at k equal 1. It's obvious at k equal 1, we have 2/3, and we have 2 to the 1 power, no? Actually, it's 4/3, because 2 times 2 is 4. Entonces, this is confusing to see here and the inside the summation. However, if you evaluate and k equal 1, now you see, this is A1. And this A1 is this. Plug it in. To determine the common ratio R, so now I propose you doing another, no? 2/3, you put 2 to the second power, no? So k equal to. Okay, entonces 8. Because 2 to the second power is 4, times 2 is 8/3, no? This is A2. Y I suppose que this continues forever, but the common ratio is A2 divided by A1, que es A/3 over 4/3. It's A/3 times reciprocal 3/4. It's obvious. This is cancel. 8 divided by 4 is 2. And this is expecting because this is a common ratio. But no. Always confusing to see this. Maybe the common ratio, no. Remember, this look like A1 R minus K minus 1. So this is confusing. Okay? This is K and this is K minus 1. We can do in this way, but no, I don't like this. I prefer expand at least 2 terms of the geometry, and you see who is the first? A1. Who is the second? A2. And the common ratio is A2 divided by A1. Now, we finish? No. This is just the beginning. Now, summation of the 5 terms, because n is 5, look, is 4/3, parentheses, 1 minus 2 squared, que square no, to the n power, que 5, to the 5th power, 1 minus 2. Okay, entonces now, this is 32, no? 32 Subtracting es 31, negative 31, negative 31. Entonces 4/3. Ajá, dice negative 31, ¿no? Yeah, because subtracting 1 divided by negative 1, no? 1 minus 2 is negative 1, negative divided by negative is positive. Okay, multiplication is positive 124/3. This is the answer. Do you see that? This is ugly formula for the summation, no infinities, m term and one summation can contain geometric sequence. Okay. Suppose number 12, no? Number 11. Number 11 is similar, same formula. Another sequence is 11, not 13, no? Or 13. This is 12, now 13. A summation from K1 to 4. Wow, it's short. So if you don't remember the formula, we can expand if you want. Either way, this is the beauty of this. Let's do it in both ways. Okay. The traditional way. Suppose I put it here 400. Oh, it's impossible to span 400. Not impossible, too long. Suppose K4. Okay, 4 is easy. 4 is when you have K1 plus K2 plus K3 plus K4. Okay, it's no big deal. K1 is, you plug in 1 here, is 1/4, no? Because 1/2 raised to the 1 plus 1. Y 1 plus 1 is 2. It's a square, 1/4. K2 is 2 here. Si es 2 is 3. Entonces 1/8. K3 is 3 here. F4, 1/16, and 4 is 5th, 1/32. Essentially, we compute 1/4, 1/8, 1/16, 1/32. You find the LCD, it obviously is 32. 32 divided by 4 is 8, times 1 is 8, so 8/32 is equivalent 100% in 1/4. Plus 4, because 32 divided by 8 is 4 times 1, plus 32 divided by 16 is 2 times 2 is 2, plus 1. Actually, we have 12 plus 3 is 15, no? 15, wow, 15/32. This is the easy way, but what is the disadvantage of this? Wow, suppose I put 400 or 40, it's too complicated. So we're using the formula. Just using the formula. A summation 4 terms is equal to first 1 minus r raised to the 4th power, que es m, divided by 1 minus r. It's the formula. The problem is I need to determine what is the first. Well, I did that, actually, because the first was 1/4. It's 1/4. So it's 1 minus, the common ratio, I don't found, but I can. Is divide 1/8, suppose division, this divided by this. It's 1/8 divided by 1/4. Okay, it's 1/8 times 4/1. Oh, this is 1/2. It's 1/2, yes. Entonces 1/2 raised to the 4th power divided by 1 minus 1/2. Okay, cool. Okay, let me try here. This is 1/4. 1/4. Here we have 1 minus 1/16. Because 1 to the 4th power is 1 and 2 to the 4th power is 16. And here we divided by 1/2, get 1 minus 1/2. Now subtraction. According to the order of operation, we are doing subtraction. This que es 1 over 4. LCD es 16, entonces 16 minus 1 que es 15. Okay, so far we have 1 over 4. Here is 15 over 16 divided by 1 over 4. 1/2, sorry. Now multiplication. Do you copy? It says 15 over 64. Welcome from 64. What's the multiplication? 16 times 4 times reciprocal of this, que es 2 over 1. Entonces 15 over 64 divided by 2 is 32. Same answer. Maybe it look like more complicated. However, it's more valid when the summation is bigger. Okay. Do you understand the last part or no? Yes, gladly. Okay, let's move to the series. Series is, you know, infinity. And the only thing you have to remember, the series converge or diverge. When it's converge, it's because the summation give me one number. And when this diverge is because the summation give me infinity. So now the only condition to be converge is the series geometry, of course, and the common ratio is less than the actual value of the common ratio must be less than 1. This is converge. Otherwise, diverges. So si actual value is greater than or equal 1, it's diverge. But one of the possibilities is not. So this is under the supposition que es geometric. Si es another series, no. Okay. Now let's move into the first example, 14, que es 5 minus 5 over 3 plus 5 over 9 plus, and this is continue forever. Bam, 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 infinity. Okay, let me try. Si I assume que es geometric, es obvio que A1 es 5. And the common ratio would be the division this divided by this. It's negative 5 over 3. Don't forget the sign. Divided by 5. And negative 5 over 3 times reciprocal 1 over 5 is negative 1/3. So we have in front of the one series, and this series geometry, if you want verification, again, you divide this divided by this, you get the same answer. And the actual value of the common ratio is less than 1, therefore it's converged. Pero converge to what value? The formula of the series is a little bit different. It's easier. Is summation infinity is A1 divided by 1 minus 1. A1 is 5. 1 minus, be careful with the sign, because the common ratio is negative 1/3. I know that the actual value is positive, but no. Actual value is to determine si it's converge or diverge. But the common ratio is negative 1/3. So you plug it in here, and double negative becomes positive 1/3. So it's 5 divided by 4/3. This is 1. You find LCD is 3. 3 plus 1 is 4, no? And now 5 over 1 times 3 over 4. Reciprocal. 15 over 4. That's the answer. That the summation, yes, it's convergent at what value? 15 over 4. That's the answer. And the second stupid series is totally divergent because it's not geometric. It's 17, actually is arithmetic. Common difference is 2. It's 17 minus, no. It's crazy. It's not geometric. When you divide, no constant. And this is divergent. And the reason it's divergent is because it's not geometric. So we need two conditions. Geometric, to be geometric, and the common ratio absolute value less than 1. Two conditions together and imply convergence. Otherwise, it's the most popular, divergent. But the most popular is that the series diverges because you're adding infinity number. Some special case que the infinity que you're adding is a small convergence, but not always que it's a small convergence. This is more complicated, and you can see in detail in calculus 2, right? Guys, I enjoy too much this semester. I am so proud to teach a student like you. I explained at the beginning of this class hard, but this class includes 2 classes. You are taking with me Color Algebra and Pre-Calculus together, right? Okay, remember, submit everything tomorrow because December 14, I grade and I posted in the Canvas and I posted in the website of the Miami-Dade College your final overall grade. Bye-bye. Have a nice day. No. Today is the last lecture. No class. Today is the last. Yeah, that's it. Bye.